What's up, dude? It does. It does. Okay, it looks. I understand. It does look. I can see the look it's giving. Okay, but remember what we are trying to do. And if you have a look at it, you should see something relatively familiar. Okay, have a look at the first two terms. You've got 2 sine squared x and you've got sine x. Cool? Look for something of a pattern. You've got a thing, sine x, squared. And you have the sine x in the next bit. If you think about a quadratic, you have an x squared and then an x. So out of the 3 terms, you've got sine x in 2 of them, one of them is a squared one. So it is actually pretty much a quadratic. I think that would probably be a good idea. What would you like to make it? Sorry? It's a non-monic, but do we care? We know how to solve non-monic quadratics. So, what do you want to make sine x? A kitten. I can't do kittens. Sine x is 5. Alright, so what do you want to make sine x? I can't do a kitten. I wonder if there's stamps. No, I won't do it at the moment. An x would be awkward. Okay, how about, what's something I can draw? Wow, nothing.
A bird, but one of those baby ones.
Oh, it's a ship. I love it. I thought you were doing a
A bathtub. Okay, the boat is sine x. Now, to be honest, this is obviously a little bit of fun, but it is actually important to note that there's nothing wrong with this. I mean, no, of course not. The whole thing is, I mean, you've got to be very, very clear on what you're doing, but I have defined a variable. I have said sailboat is sine x. Is that, realistically, is that any difference to saying u? No. Not really. U is just, it's a letter of the English alphabet and it's the way we write it. But back in the dim dark ages, they didn't have the same numerals that we use. The same digits weren't the same. They weren't written the same. Yeah, hieroglyphics. I mean, pictographs and all that sort of thing. So I wouldn't recommend doing this in the HSC, but it is very indicative of the fact that algebra is just a symbol to represent an unknown. And what we've defined it as is this boat is equal to sine x. There's nothing wrong with that, as long as you are consistent and you know what you're doing. Okay? Well, just, yeah, don't, I mean, use a kitten if you can. I mean, if you've got a stamp, use a stamp. No. Someone will hear this, Mr. Dwyer will hear this and he'll go, hang on, you're telling them to do what? So, all right, but we're defining the boat as sine x, and that's fine. So we've got 2. The reason you probably wouldn't do it like this is because it takes longer to draw. So we've got 2 boat squared plus boat minus 1 equals 0. Happy with that? That's now a quadratic. It's a non-monic, as you said, but it is a quadratic. Now, the reason that it can be a little difficult when you're using boats, but there's a 1 in front of that. So you've got 2 boat squared plus boat minus 1. 1 boat there. Cool? So now you have to factorise it. So what are you going to end up with? I'll draw my boats. It's a non-monic, remember? Do you guys remember how to do non-monics? Times. And to be honest, this is a very, very simple one. Haven't done them in a while. Pretty much. I'm just going to write it up there. So you're going to have 2, okay, in that one. I'm just going to write it up and we'll go through how you do, oh, not a U. You do non-monics again later, because I don't want to spend time on doing non-monics, but we'll go through that again in a minute so that you can remember how to do it. I'll do it as a separate video, because that way I get more hits on my YouTube channel. Westy, we're doing boats. Huh? On cool video. What do you mean? This is cool video. Oh, okay. Even I can't stick with that. All right. So what do we got? So we've got 2 boat minus 1 and boat plus 1. So what's our boat equal? Close. Minus 1 and? It's not going to be 1. Because you've got 2 boats. What value of boat can you put in there to get 0? 2 times a half is 1. Minus 1 is 0. So your boat's going to be a half. Cool? All right, so they're your two values. But we know that boat equals sine x. So therefore, sine x equals minus 1 and a half. So, and don't forget, we are only doing between 0 and 360. So now you have to remember what your values of sine are. Okay, so using trig. Now, we do have them up there on the side. Okay, or you can remember your triangles. Do you remember your triangles? Okay, that's your unit circle, so you can use that. Well, we've got sine x equals a half or minus 1. So what we have to do is work out what value of x. In other words, what angle, when you do sine of an angle, what angle is going to give us minus 1.5 between 0 and 360. Let's use ASTC. It's probably the easier way to go for you rather than drawing. Personally, I draw the sine graph. I just use sine curve. Okay, but I know it off the top of my head. You don't? That's fine. ASTC. So we're going between 0 and 360. But is that going to help you? Are you going to be able to work out which angles are going to give you 1? No. This will help you which one's positive. So you could sort of go, well, this is positive, therefore it has to be in that one and that one. This one's negative, so it has to be in that one or that one. But is that going to actually help you? No, probably won't. I'm going to get rid of that. ASTC. You did, and that's awesome. I'm not sure if you remembered it in the right order, but you remembered it. Yeah, but it's going that way, remember, not that way. Most people would have gone clockwise. ASTC, you've got to remember that it goes clockwise. Anti-clockwise, sorry. Okay, just checking that you remember. Jeez, you're narky, isn't he? All right. There's your sine curve. What's a sine curve look like? Excellent. Where's it start? Okay, I'll give you a hint. There's 0, there's minus 1, there's 1. No. Yeah, it starts at 0. So at 0 degrees, it's at 0. Cool? Then it goes up, down. Keeps on going forever. Okay. But now you have to remember where it changes. So in other words, where does it get back down to 0? Or, better question, where does it get back to 0? Where does it complete one go? Yeah, so it's gone from 0 up to 1, through 0, down to minus 1, then back up to 0, and then it starts again. It starts repeating. Where does it start repeating? 360. Thank God you're here. That's how he rolls. ASTC. Before you disappear, we've got a couple of seconds. Let's finish this off. Okay. What's that going to be then? The middle one. 180. Cool. Where's this going to be? 90. Where's that going to be? 270. Awesome. What's the value up there at 90? Cool. What's the value at 270? Cool. That's 0 and that's 0. Would you agree? Okay, what were our options? Minus 1.5. So where is it minus 1? 270. Cool. So, minus 1. Does that look good so far? Hang on, well, I'm going to pause because this is going to take us a couple of minutes. So I'm going to pause and then we'll come back to this one.